Good morning, ladies and gentlemen. I don't know if you can hear me or not. Can you hear me? Oh yeah, I bet you can hear me now because I can almost hear me now. Here we are again. It's great to see the old faces and some new faces. I don't know. First, I guess I want to welcome you to the Mile High City. Recent legislation was passed, so this is now the higher than a mile city. I'm pretty straight arrow myself. I've never had marijuana, so I'm going to be sure to stay straight arrow for you guys so that I can continue to speak in coherent, if not cohesive sentences. I don't know, for those who are members of the Wake and Bake crowd, we're going to have Cheetos and pizza later. For those of you laughing, thank you. For those of you not, I'm terribly sorry. Next on my agenda is to thank our sponsors. We couldn't do this without them, and we're really grateful for the cash. Thanks for the cash. We sincerely hope that you get out of this event what it is that you need to get out of this event in order to make your bottom line. Gold sponsors are Intel, Seagate, Cray, DDN. Thank you all. Our silver sponsors are Dot Hill, Warp Mechanics, and Aeon Computing. I guess, you know, I want to thank the community at large. We got a fair number of abstracts this year, and you know, like I do every year, I would encourage each and every one of you next year, submit an abstract. You know, tell us what you're doing, tell us what you're up to. Often, you know, people find themselves in the position like, well, you know, we run a production system, we're not really doing any research. If you haven't given a presentation, send us some stuff. We'd like to know what you're up to. Bearing that in mind, I want to thank the program committee. Year after year, we have stalwart and brave citizens who are willing to take time out of their ridiculously busy schedules, read abstracts, meet and listen to me yammer on. So I'm very grateful for that part. Let me roll down the list of names. Michael Conley, Megan McClellan. Megan can't make us. She's with us. She's having a kid. So all the best to her for that endeavor. Sarp Oral, who couldn't be with us. Mark Gary, who can't be with us. Fei Yang from Oak Ridge. Parks Fields from Lannel. Orléans de Gramont and Stéphane Thiel from CEA. They're members of UFS, and they are excellent participants in this process, and we're really great to have them on the committee. Sébastien Buisson from Bull. Peter Jones from Intel. Jesse Kasman, who is our press guy. And, you know, Steve Monk, our faithful timekeeper. So if you're speaking, pay close attention to him. He's got the crook. So this, I guess, is really my first time doing this. This is kind of experimental. I'm going to give a talk now. I'm going to take off my jacket because I'm, going to get to work here. I'm not sure I had enough caffeine this morning. I didn't want to dry myself out, this being the Mile High City and all that. How many of you here are new to Lustre? 1, 2, 3, 4, 4, 5. This bud's for you. For those of you that are not new to Lustre, I hope you find this reasonably entertaining. Is this thing on? There we go. The title of my talk is Choose Lustre. This is something that Indiana University has done, and this is something that everyone should do. This is the hard drive on a researcher's desk. possibly it contains really important data, data that they've probably spent their entire life working on, data that needs to undergo some sort of computational whatnot. In their laboratory, they might have a machine that's, you know, a couple years old. Maybe they got a grant. Maybe it's a brand new machine. Well, you know, when when you need to apply 4096 cores to a problem, that's not going to cut it. So we bought half a petabyte in 2006, which for the time was a big deal. But we thought that maybe we would scale it. Now, scale for Chris Marone and scale for me, very different things. But clearly, Lustre will scale to ridiculous sizes. Now, say you want to move your data from your disk to your compute. Maybe you're doing this across USB. Some people I hear are still using NFS. Lustre's fast. At Oak Ridge, we're seeing a terabyte a second, crazy speed. So maybe you've got a compute cluster. You've got some clients, and you know, maybe you're plugged into that GigE switch that you've got. Well, Lustre supports many thousands of clients. So, you know, scalability in size, scalability in speed, and you can support tons of clients. Hey, this is a hot one. Lustre is open. Well, that's cool. I mean, that means that you can look at the code, you can change the code to suit your needs, something that IU's done some of. It means that, you know, you can you can use your file system without somebody jacking the cost of your licenses. You know, there's that other file system, they sell you more or less a black box. Free like beer, huh? Not exactly. It's kind of free like a puppy. Right? You know, you find yourself, you go down to the animal shelter and, you know, you find one that you really like. The tail wags really fast. It barks at just the right volume. Well, face it, it takes a lot of work to maintain Lustre. Lots of stuff to do. And these are things that, you know, people don't really think about, right? You pick your vendor, you know, maybe you buy a Lustre support contract through them because you want one neck to strangle. But, you know, there are associated costs that you don't see. Somebody's got to fix the bugs, somebody's got to test the software, somebody's got to plan a roadmap for features, and then someone else has to develop those features. And then there's the issue of documentation. Getting engineers to write documentation, I mean, that's like blood from a turnip. It's tough. But somebody's got to do it. If you're going to use it, you want to know what the features are and how to use them. And you got to, you know, so maintaining the documentation is entertaining if you're like constantly changing things. I remember in 2006 being in Colorado, watching a sort of Lustre internals presentation, and there was somebody else with the associated company who periodically would say, boss, it's not really like that anymore. Now I can relate to this being a manager, but you know. So things change quickly. Somebody's got to host the tree, and somebody's got to review the code. Take a look at this. This is a, you know, sort of pie chart of how much code was contributed by whom. You know, that's not the real issue. I mean, it's kind of neat to look at, but the big deal, there are 15 different organizations right now that are contributing to the tree. Now, that's frankly not many. So we need you, if you are a C programmer or know a C programmer, we need you to wrap your head around Lustre and start digging in and helping us do some things. Now, In my experience, having managed some of these people or worked closely with these people, you will find a project on SourceForge, and for a very limited amount of time, everybody's incredibly excited about it. It's the whole, we built it here, we're going to use it here, we're going to try to get other people to use it, and then interest fades, and you find there are tons of projects that have been abandoned on SourceForge. Luster's not that deal. Now, we had a bump in the road. So there was a whole year between releases, between Oracle having Lustre and then the community kind of getting involved and pushing things forward. But we've got a release cadence now. We're having a release in the fall, release in the spring. And by and large, users are following the releases. Right now, as Baron will tell you later, the majority of Lustre users right now are using 2.5. 2.7 was released not too long ago. And I think that speaks one to what we're doing as OpenSFS, providing features, providing testing, and in addition, the user interest in what we're up to. So, I don't know. Let me stop now. Do you feel the spirit? No, I'm just kidding, mostly. So, Lustre. It's a parallel distributed file system. It's used by more than 60 of the world's top 100 supercomputers. Lustre is crucial for their operation. Lustre is crucial for our operation. So Lustre is crucial for a lot of operations. We would like to see Lustre, of course, expand into new markets. Small file performance is something that everyone's concerned with, and we've made great strides in that arena. So we could see Lustre moving into the bio market for sure. Those guys have a lot of 0K files. That's something we can talk about offline. Lustre, it's POSIX compliant. That means your researcher that knows Unix is going to be able to use it. Open, write, close. These are all good things. So, one of the things that's cool about Lustre is it separates big I/O from small I/O. Some file systems have sort of interleaved their data and metadata. But that's kind of weird because you have like large block writes, small block writes. Lustre separates them out. Metadata server is responsible for tiny reads and writes. Object storage servers are where the data lives, and those are large reads and writes. 1 meg size, or these days 4 meg size. And as you can see, I've got more than one MDS in the picture. This is a picture I've used periodically, but I had to update it when we got multiple metadata server D and E. I was always trying to figure out what the E stands for. I was like, distributed namespace E. I mean, what does the E stand for? I mean, is that it? Distributed namespace environment, thank you. So your metadata server, it's responsible for directory operations, files open, close, the file status, etc. Your metadata target really is where all that stuff lives. So there's MDS, MDT. I don't know, for those of you that know all this stuff, you can sleep. So the data resides on the object storage target, which is attached to the object storage server. So the simplest Lustre system that you can have really, client, MDS, OSS. You're going to get these slides later, so I'm going to accelerate. Lustre, it does parallel I/O. You have multiple RPCs going from compute node to object storage server. I mean, the way I like to think about it is that your compute node wants to write. It talks to the metadata server, which then gives you name, address, phone number, shoe size of where you want to put the data. You can then stripe this data. This is one of the things that I think is way cool about Lustre. IU has a crazy mixed workload. I mean, we have well over 100 disciplines that are all using our supercomputer. Their workloads are crazy different. So you'll get a call from somebody that says, hey, yeah, I've got a 6 terabyte file that I'd like to put on the system. And in terms of your sort of object storage target, you're like, man, you know, if you drop that on one stripe or one object storage target, that could fill it up in a hurry. So that's why you can stripe files. Striping increases performance, as we'll see in a moment. And you know, with DNE2, you can actually stripe directories. So, but you know, we got a presentation on DNE2 on Wednesday. So I hate to say this, but it's really analogous to RAID 0, right? It's like the next abstraction layer. So if you're writing to a server and the server has a RAID array, you can stripe that data from the server onto the disk. But if you back off one level, you can have multiple servers, and your client stripes to those multiple servers, which in turn, you know, stripe to the disks. So that's one of the ways that Lustre speeds things up. Here's a simple striping example. Again, you'll see these later. It's going to take me a second to explain these graphs. It's a little cryptic, but I'll do my best. This is data from a live file system. One of my compadres at IU, Robert Henschel, he runs the Scientific Applications and Performance Tuning Group. So he will launch IOR jobs periodically at the file system just to see how things are going. And he runs a 1-process job, you know, 1 process, 1 file, and a 4-process job, 4 processes, 4 files. Now, the blue is a single stripe. Okay, and I guess the black is a 16-way stripe. The gold, I guess, is an 8-way stripe. So what we're looking at really is a reflection of where each job falls over the course of a month. So you can see that you know, you get a huge performance boost for doing a 4-way stripe relative to a 1-way stripe. And this is the case for 4 processes as well, so 1 and 4. And again, you know, the numbers at the bottom are probably so small that, you know, you need opera glasses. But luckily, you'll get a copy of these later. These are reads, and again, the scale is different. But again, you can see that you can get increased performance by striping, you know, 4, 8, 16 ways. And that's the same with the 4 processes. So what am I saying? I'm saying, 1, choose Lustre. It rocks. 2, this is more or less the building blocks that make up Lustre. And lastly, my favorite feature, at least, is the fact that you can stripe your data. Let's imagine now, you know, you've got a file that's bigger than your object storage target, or bigger than what's left. You can fit that file on the file system by striping things. Once upon a time, I worked at the Children's Museum in Indianapolis, and we had a bed of nails. And you know, one of the demos that we did was to step on the bed of nails. So you know, I'd step out of my sandals and onto the bed of nails, and the kids would go, oh, you know, and you'd tell them, well, you know, what if I stepped on 1 nail, right? It just goes right through. But Lustre's fantastic because, like a bed of nails, it really can help distribute the load, and you know, not bring down an object storage target. This is kind of a summary about Lustre striping. You know, how am I doing, Steve? Wonderful. Anyway, so you can increase your bandwidth. It permits you to take huge files and distribute the load across multiple object storage targets. You know, disadvantage, well, one is sort of user overhead. That means you kind of got to think things out. You know, are these big files? Do I want to stripe them? Are these small files? Do I not need to stripe them? And you know, there's some additional overhead For example, if you do an LSL and you want to see the absolute current size of a file, your MDS has to contact all of the object storage servers on which the data rests. Are you my mother? Are you my mother? Are you my mother? And then it, collates that data and hands it back to you. And the caveat is don't just stripe everything, because it's not going to benefit you all the time. There you have it. Scales, it's open. It gives you, as the user, puts you in the driver's seat in terms of how your data is striped, the kind of performance that you want to see. Right now, there are tons of different tools to help you with installation, some of which are open, some of which are closed, all of which will get you to where you'd like to be. I don't know, you guys know Tom Waits? Flays it chops, Ruse, household orders. It's called, what, Step Right Up. It's on the Small Change album. I recommend it. Let's see. Even the Colonel wants to choose Lustre. So, thank you. I got one question. Anybody fans of Neil Young out there? Yes, no? I've been hearing the song "Don't Let It Bring You Down" all day. It's only castles burning, so find someone who's turning and you will come around. So if anybody can explain to me what that means, I'd like to talk to you later. Questions, comments, cliches, other words that begin with C. Bless you. Thank you.